Good afternoon, everyone. In this video, we will discuss research methodology assessment detail modeling the spread of dengue fever by taking into account mosquitoes population dynamics. First, let's start with the background. THF is a serious public health problem in tropical regions. The main factor is the Aedes aegypti mosquito, which spread the dengue virus to humans. Rainfall also play an important role because it increases mosquito breeding sites that cause mosquito population to grow during the rain season. As a result, dengue cases usually increase significantly during rainy season. Therefore, this research focuses on the relationship between rainfall and the spread of DHF. The second is research gap. Many existing models still have limitations because they cannot fully capture the real seasonal dynamics of mosquito population in the real world. Most models do not clearly include gains because by rainfall or seasonal shift, even though these factors strongly affect dengue transmission. Therefore, there is a need to develop a mathematical model to consider seasonal change, so the analysis can become more realistic and accurate. The next is a research problem statement. Uh, for the first, mosquito population fluctuate because of rainly and temperature change. Thus, an environmental factor affect the spread of dengue. Second, traditional series models usually assume constant population, so they cannot fully represent real-world conditions. As a result, there is an analysis gap where existing models cannot clearly explain the increase in dengue cases during certain rainy periods. Therefore, this research aims to develop more realistic mathematical models that include seasonal factors.
Okay, next I will explain the research question. Based on this, there are two research questions. The first, what mathematical model can be used to describe the spread of dengue fever while taking into account change in the mosquito population? And the second, how do seasonal factors, particularly the rainy season, affect the increase in mosquito population and the number of dengue fever cases? Next, the research objectives are to answer the research question. That is, the first, to developing a mathematical model of dengue fever transmission that takes into account change in the mosquito population, and to analyze the impact of seasonal factors, particularly the rainy season, on the increase in mosquito population and the spread of dengue fever. Next are the research variables. In this proposal, the variables are divided into two categories, independent variable and dependent variable. The independent variable include the human population SH, that is the population at risk infected, and RH, that is the recovered population. Mosquito population SV, that is mosquito population susceptible to infected. Red parameter, that is mu H, mu V, and gamma H, as well as seasonal vector, that is gamma of T. And the dependent variable in the study include the unit number of infected humans and mosquitoes. IH, that is the infected human population, and IV, that is infected mosquito population.
Okay, next, I want to explain the mathematical model we use in this research. The model we developed called epidemiological model, the SIR model, which stands for susceptible, infected, and recovered. What's special about this model is that it considers two different populations at the same time, the human population and the mosquito population. Let's look at the equation for the human population. We have three equations here. The first one describes the change in the number of susceptible humans, the second one for infected humans, and the third one for humans who have recovered. This equation shows how people move from being susceptible to getting infected and finally recovering or passing away. Next, we have the equation for mosquito population. We also have two equations here, one for susceptible mosquitoes and one for infected mosquitoes. I want to emphasize here is the function gamma t that you can see in the first equation for mosquitoes. Gamma t is a function that changes over time. This is the key part of our model because this function represents the influence of seasonal factors. So it allows us to show how the mosquito population grows or decreases depending on the season, like during the rainy or dry seasons. This makes our model much more realistic and accurate in describing the actual condition in the field. Next, let's talk about the research methodology. This study uses a quantitative method with a mathematical modeling approach. Our main goal is to analyze the spread of dengue fever by considering how the mosquito population changes due to seasonal factors. We do this research in 8 main steps. First, we identify the problem, then we study related theories in the literature review. After that, we develop the mathematical model. Next, we define all variables and parameters and set the initial conditions. Once ready, we run the model simulation. Finally, we analyze the result and drawing conclusions. Next, in this conclusion section, this study develops a more realistic SIR mathematical model for dengue transmission by considering mosquito population dynamics influenced by rainfall. The model shows that increasing mosquito populations can increase dengue cases, especially during the rainy seasons. This study is expected to help health authorities create more effective dengue prevention and control strategies. That's all. Thank you.
Audio Jungle.